Today we're going to solve absolute value inequalities. Remember, absolute value means how far a number is from 0. The absolute value of x is less than 9 means all of the values less than 9 away from 0, and all of the numbers in between. So our endpoints go from 9 to -9, including all of the numbers in between. If we try one of these values, we find we get a true statement. For instance, if we plugged in -4, the absolute value of -4 is 4, which is less than 9. We use open circles for our endpoints because the less than does not include the or equal to. Our solution can be written as an and statement. It's a compound inequality. X is greater than -9 and x is less than 9. We can also write it in this way, where the x is in between the -9 and the +9. Let's try another example. The absolute value of x is greater than 3 means all of the values more than 3 or equal to 3 away from 0. That means that x can be greater than or equal to 3, or we want it to be more than 3 away, which would be -3 and all of the numbers smaller than -3. This time we use a closed circle because our inequality symbol includes the or equal to. Let's try one that's a little harder. This time we're using the absolute value of x plus 3 is greater than 8. The inside of the absolute value has to be more than 8 away from 0. So this time we're going to take what's inside the inequality symbol and make it greater than 8. Or if we go to the negative end, we make it smaller than -8, so that what's in between the absolute value symbol is greater than 8, or it's less than -8. And then we're going to solve each one of those. So x could be greater than 5, or it can be less than -11. So if we look at our endpoints, we use open circles because it's greater than, not including the or equal to. And again, we end up with an or statement. It has to be more than 8. Let's try one last example. This time we have 5x plus 1 is less than or equal to 16. Or the absolute value of 5x plus 1 is less than or equal to 16. Again, we want what's inside our absolute value symbol to be less than 16 away from 0. So we are going to take what's inside our inequality symbol, the 5x plus 1, we're going to make it less than or equal to 16, and we want it to be greater than or equal to -16. So this time we're writing our compound inequality with the 5x plus 1 in between our two endpoints. Then we're going to solve each one of these. So a review on how to do that. When we have our 3 pieces, we can subtract our 1 from all 3 of those pieces. We're trying to isolate our variable in the middle. So on this left side we have -17 less than or equal to 5x, which is less than or equal to 15. And then to finish, we divide each one of our pieces by 5. Remember, on these ones we have 3 pieces, so we're going to divide all 3 parts by 5. So on this end we have -3 2/5, which is less than or equal to x, and that's less than or equal to 3. When we look back at what we've learned, what can we summarize? Right? On this example, we had a less than, and we ended up with an and statement. And if you look back at all of the other ones that we've done, you'll see that if you started out with a less than or a less than or equal to, we get an and statement. Our range has to be within those, so we're looking for our overlapping section. If we have a greater than or a greater than or equal to, we end up writing an OR statement. Today we're going to solve some absolute value inequalities. Remember, absolute value means how far a number is from 0. The absolute value of x is less than 9 means all of the values less than 9 away from 0, and all of the numbers in between, which means our endpoints go from 9 to -9 with all the numbers in between. If we try one of these values in our inequality, we find that we get a true statement. For instance, if we plug in -4, the absolute value of -4 is 4, which is less than 9. We use open circles for our endpoints because the less than does not include the or equal to. Our solution is a compound inequality. X is greater than -9 and x is less than 9. We can write it in another form as well, with the x in between -9 and 9. Let's try another example. The absolute value of x is greater than or equal to 3. This means all of the values more than 3 or equal to 3 away from 0. So this time our endpoints are at 3 and the number is more than 3, or -3 and the number is smaller than -3. We use a closed circle this time because our inequality does include the or equal to symbol. And again, if we try one of our numbers, for instance 4, the absolute value of 4 is 4, which is more than 3. Let's try one that's a little more difficult. This time we have more inside of our absolute value symbol. We need to take the inside, and it has to be more than 8 away from 0. So we're going to write two inequalities. One, x plus 3 is greater than 8. And our other one, on the other end, that absolute value of what's inside the absolute value symbol has to be less than -8. So we take the x plus 3 and make it less than -8. And we connect those with an OR. When we solve our inequality, we get x is greater than 5, or x can be less than -11. When we graph it, we use our open circles, and our arrows are pointing out. This time we have the absolute value of 5x plus 1 is less than or equal to 16. What's inside our absolute value symbol this time is the 5x plus 1. So that has to have a value that's less than or equal to 16, or greater than or equal to -16. This time we're going to write it as a compound inequality, with our 5x plus 1 being greater than -16, or it can be less than or equal to 16. When we go to solve this one, remember we take 1 away from each one of our 3 pieces, leaving us -17 is less than or equal to 5x, which is less than or equal to 15. And then we divide all 3 of our pieces by 5. And that leaves us a solution of -3.4 is less than or equal to x, which is less than or equal to 3. And again, this is one of our AND compound statements. So x is greater than or equal to -3.4, and x has to be less than or equal to 3. If we look back at the ones that we've done, all right, we can summarize. If our original inequality started with a less than or a less than or equal to, we ended up writing an AND statement. If we started with a greater than or a greater than or equal to, we ended up writing an OR statement. Remember, you need to write 2 inequalities, one using the positive and one using the negative, which reverses our inequality symbol.